Hey, agentic engineers, we've been fighting back, we've been building code, we've been shipping more stuff than we've ever shipped before. Things have been going great. But there's an elephant in the room right now, and that elephant is the amount that it costs in order to run a lot of these jobs. We have different members of our teams that are taking on different parts of work. They are building out their stuff, and they're burning Inference as well. Why is this? Well, the main reason is primarily is that we are not adding our parts to the spec. Now, what does this mean? Okay, so if you've been following along, you know that there is three main pillars to the agentic workflow. There's the propose. This is the spec. This tells us what we're going to do. This tells us the piece of work. There's the acceptance. Now, the acceptance has been something that was only for the engineer. In this video, we changed that. And then we have the execution. Nothing changes here. So let's open up open code. And if you're using the agentic framework, you can use either Claude, OpenCode. You're going to get the same thing out of it. So what we're going to do here is always a good idea is to basically just run a prime. You'll see the prime skill here. This is the universal skill that is for OpenCode, Claude Code, PyAgent, and is part of the core of the agentic engineering framework. So this is just going to basically run through, give an update on any commits that our team has done, things of that nature. So what are we going to do now? We want to create a feature. So this is something that a project manager has sent to the team, and it's going to affect all the different parts of our team, right? So let's say we're going to do something simple because this is a video. So we're going to say prime skill and, oops, not prime skill. We want a feature. Feature. So what is this feature? We would like to add a Web3 login to our game. We are focusing on the base Sepolia network and MetaMask users. Okay, very high level, very easy to put together. Now, when we are creating this feature, think of it as the product manager and has given our team a set of tasks or just an overall goal. We want the X feature. Now, X feature could be based into UI, CI/CD, API, smart contracts, et cetera, et cetera. Now, when we're creating this plan and this spec comes out, there's going to be something in the future that you're going to want to see. We are going to want to experience that there is each area of the engineering team and even the parts that don't exist, right? We create them, we template them, we figure it out. But each of those parts are there. Now, how do we save inference? Inference is saved because on the onslaught of the feature itself, we have defined all the different parts of work. So when we pass, or when this job gets created by our agent or our team of agents, and we have engineers come in to review the parts of the work that would directly affect us, or the parts of work that maybe we are maintainers of those skills, engineering workflows, et cetera, et cetera. The top heavy part is already done. You don't have 5 engineers all doing the same thing or separate parts of one thing. You have one upfront cost to 80 to 90% of the work that needs to be done for a specific feature. So that's what we're basically going for. Now, right now, this spec is going to be created. And now we can review the piece of work. And you can tell, like right now, the cost of inference for what we have just done, was 13 cents, which is great. Okay, and now we have Web3 login with MetaMask. Yeah, this looks good. The user story looks fine. A problem statement. That sounds pretty consistent. I'm not going to bore with going over every part of it, but you can see that it has like the relevant files, what new files it needs to create, an implementation plan for the phases that it has, the steps, what it needs to create here, the auth layer. Let's get into some parts where it does some acceptance. Okay, here we go. It has like this testing, a testing strategy, unit test, integration test. It has some edge cases. This looks good. This looks good. And the one thing that's amazing about this part as well is that when we as a team are going through this, markdown file, or this has been generated, and this could be generated by the product manager itself. And the product manager could actually go on and implement this. So let's look at how another part of this workflow would be. So we're going to use our / commands, and we're going to go into our implement phase. Now the implement phase has all the necessary skills. It knows how to read this piece of work. It knows how to, divvy it off and what skills are there. Now this is actually a really good part too, because when we are building out in this phase, we're going to find parts of the system that need updating, or there may be specific, skills or workflows or templates that don't exist that, the engineering team needs to build out and test. So, and we're going to say at specs, and we have our Web3 MetaMask login MD. So this is the piece of work that we are going to fire off. So we'll fire it off, and on the right bottom corner, you'll see how much that this particular feature using Kimi 2.6 on Venice API actually costs. Let's go. Okay, great. So now we have a full feature from the propose, the acceptance, to the execution, all for $1.10. What is the big takeaway from this? The big takeaway is that if you have a really detailed plan before you build out your features, you're going to save yourself 10x the money on what it's going to cost. The majority of time, if you saw this feature built in something else, it would be north of $10 to $15. But the plan itself, the spec itself, is what made it cheap. Not the model, not the harness, but the plan. I'll see you in the next one, engineers.